some cold weather, the furnace is kicking on, it's running. Now, if I bump the thermostat up, it gets hot and then it shuts off and then I'm cold again. It drives me absolutely nuts where I 100% know if I had the MultiPRO running right now, the walls would be warm, the floor would be warmer because it's going to be slowly bringing the temperature up to where I'm not sweating, but the space is at a comfortable temperature.
Hi, I'm James McIntyre, Senior Director of Commercial Sales. Got Daniel Hamrick.
Good afternoon, everybody. I'm Daniel Hamrick,
There you go.
Director of Problem Solving, Sales for the East Coast. And we got JD.
Hello, I'm JD. I'm with the tech support and also a trainer for the residential side.
Awesome. Well, I hope everyone had a good break. Welcome to 2026. It's going to be a great year. Yeah. Confetti, all that. If you didn't have much of a break, I hope you made a lot of money. So welcome back to Talk and Comfort Live. If you're on a job right now and have a question, please call the tech line. Otherwise, you can submit questions anytime using the question mark icon to the right of the screen, and we'll be checking that throughout the show. We have a great agenda today. We're going to be talking about cold climate capabilities, the green ultra heat difference, the gas versus dual fuel versus electric, blaming temperature fluctuations on controllers. We're going to be doing the Gree Responds segment. And let's see here. Cold climate capabilities. Let's see. And we'll take a minute to tease AHR and upcoming training. And if you weren't able to join us live, there are links in the description so you can choose your own adventure and jump straight to your segment of choice. All right, so let's start talking comfort. I want to start with our misnometer. What does our misnometer say today?
Oh, yeah. So I can't believe here in 2026, we still get this. Heat pumps only belong in warm climates. So the outdated myth. Many contractors and homeowners still believe heat pumps stop heating when it's cold. That belief is based on old technology. I just recently heard this from my sister. She's like, "Oh, well, I know heat pumps don't put out as much heat as furnaces do." Well, I installed a flex on her house. and now she's quite comfortable and enjoying the 115 plus degree heat that thing puts out all year long in Georgia. So no worries there. It might not be quite furnace temperatures, but you don't feel that draft. So what changed, JD?
Gree did a lot of things. They designed a compressor that can go, that has the hot gas bypass or hot injection gas that helps it go down to -22, and new refrigerants and all kinds of upgrades to help it get down to negative. Like a lot of our units are -22, so we're trucking at 0 degrees, no problem.
Yeah, for sure. Inverter-driven compressors. We're selling heat pumps in Alaska, so
right.
It's not
Canada,
the heat
Alaska.
pump of yesterday.
Oh yeah, North Dakota, Canada.
It seems like we talk about this a lot, but it's January. It's cold most places, except here where I'm at in South Carolina. It's a sunny, bright 65-degree day. Almost have to turn on the air conditioner.
Here in Dallas, it's 77.
Is it?
Yeah, and I do have the air conditioner on.
Oh, geez.
So
it's 65 where I'm at.
Oh, wow.
I don't know what kind of winter this is.
Yeah, it's a weird one.
Well, I kept seeing these warnings about the polar vortex and everything getting really cold, and I'm expecting a blizzard in like March probably,
Yeah.
Oh
just to
wow.
throw us off.
If I mean, if it doesn't get cold soon, I'm gonna have to cut grass again. I don't like the
Yeah,
fact that I keep having to cut grass.
my Bermuda's starting to green up a little bit. I'm worried.
Yeah, I've got butterflies and dandelions in my yard.
Oh, that's weird.
What's up with that?
uh, let's talk about degree ultra difference.
So, I mean, so we could discuss how GREE ultra compressors push modern inverter-driven technology beyond efficiency and into year-round comfort, even in cold climates. Because we never talk about this ever, right? We
Right.
never talk about this at all. Um, one of the things that like what JD said, is the hot gas injection. I mean, that's pretty much anybody's going to be able to do that. And one of the things too that is, I mean, excuse me, any of the technologies out there that are like, let's just name names: Red, Aurora, Hyper, whatever it is. They're all effectively doing the same thing in that regard. Um, However, we are capable of producing that much more heat than even those. We've ran the numbers ourselves. If you go looking for their heating capacity charts and all that, you can do some comparisons yourself. One of the things that always got me, JD, since you live in Missouri and given who we used to work for,
Yeah.
I got my sister needed a furnace, and I called up one of our old coworkers and I said, what kind of furnaces do we have? And he's like, well, we can get you like a 54,000 or a 72,000 in that 3-ton drive. And I was like, okay, so I guess I would go with a 54. And he's like, yeah, you live down there, so you should probably get a 54. And I'm like, why is it the gas furnaces are sized so much larger, like that, even like for southern climates? Why are they so much bigger like that? And to your point, like you said earlier, Daniel, when you're talking about a gas furnace putting out hotter air, well, like, of course it is, right? I mean, call us a 72,000 BTU furnace. It's going to put out hotter, you got a higher delta T, but it also does it in a shorter amount of time,
Yeah.
right? So when you say 72,000 BTUs per hour, are you getting 72,000 BTUs when it's on? No, you get 72,000 when it's on for an hour,
Right.
right? So when you're comparing that to a heat pump, like let's say it's putting out 36,000 BTUs, it might have to run twice as long as the furnace. But what does that really mean? Maybe I'm running 10 minutes an hour or 15 minutes per hour or something like that versus like 20 or 30 minutes.
Mhm.
But it also cuts down on those temperature swings, that kind of thing. But
Well, and I know that's kind of moving a little bit into our next segment, but I just have to I have to bring it up now since you're talking about it. Like
right,
what really gets my goat in the wintertime. So I've mentioned this before. There's a MultiPRO going to be on my house eventually. But I travel a good bit now with this new
yeah,
position, so I'm not here long enough to get it done. But I kind of set the project to the side because I wanted to see how the winter went with energy costs and things like that. And
right,
so what I've noticed is the house is always cold. Now, the past couple of days it's been warm, but we've had some 23 degrees, some cold weather. The furnace is kicking on, it's running. The walls, the floor, everything's cold all the time. Now, if I bump the thermostat up, it gets hot and then it shuts off and then I'm cold again. It drives me absolutely nuts where I 100% know if I had the MultiPRO running right now, the walls would be warm, the floor would be warmer. It's on a slab, not a crawl space, because it's going to be slowly bringing the temperature up to where I'm not sweating, but the space is at a comfortable temperature.
so you're saying you're dumping in a bunch of heat,
Yeah.
you're satisfying the thermostat, you're losing a bunch of that heat right back into the floor, right back
Yep.
into the walls and everything else. And so you're just kind of having this temperature swing going. And of course, we don't want that to short cycle. So we'll have, time delays
Mm-hmm.
like in our thermostats and those smart thermostats that everybody has. They
Yeah.
have those built-in time delays. So you just have this pretty wide range
Yep.
because it can only run so long, right? You can only provide that many BTUs for so long before like how hot do you have to get your house before it truly satisfies? So I know what you're talking about. So I guess in a lot of ways, when we used to talk about cold drafts and all, maybe that's what we're talking about. It's not necessarily that there's a bunch of heat outside. It's just, trying to get everything to the temperature that you're wanting to get to. I mean, once your floor is 72 degrees, once your walls are 72 degrees, you should be able to maintain pretty good.
Right.
But kind of hard to get there if you're doing it like lighting a torch to heat up your living room. It'll be like 1,000 degrees,
Oh yeah.
and then it cuts off. But
It's kind of like the gas, fireplace. It gets really hot in that one room.
yeah,
Nope.
it happens pretty often. About what if it's cold in the morning, cold at night, or whatever. My wife will use the gas logs a little bit, and what stinks is having them on in the morning, and then you're like, okay, I guess I'll open windows now because it's going to be forever until that fireplace isn't hot anymore.
Yep.
So,
Yep.
so now, let's talk a little bit. When we're talking about gas and all that, we're obviously already doing comparisons. So, let's go with gas versus dual fuel versus electric. I mean, we're kind of already talking about it anyway. But with just straight gas, yeah, like we said, you can have the it comes on, you blast really hot air. I mean, hot within certain limits, right? Of course, turns off, it gets cold, repeat, like you're saying. With heat pumps, you do have a lower discharge temp generally. There's a lower delta T, and it's going to run longer. And we've done a lot to try to train folks to stop thinking about something running longer, therefore it's using more energy. Because I mean that's the way we've always thought about everything, right? If you take a
Right.
standard compressor or a furnace and it's just on, it's on at 100%.
That's what smart thermostats do, right?
That's what
They
smart
keep it off
thermostats
as much
do.
as possible.
And that's the way that everybody's always kind of thought about saving money. It's like, what can I do to just keep it off for as long as possible?
Yep.
But
Yeah, bigger temperature swings.
right
Yeah.
now, with mini splits, since they were the first, I mean, really the first to try to take off with inverter-driven, variable capacity systems, that's what's commonly used throughout the globe. They're trying to save as much energy as possible. We've always had the benefit of our energy being relatively cheap. I mean, if you ever see what energy costs are, like, globally, I mean, I
We're
love
lucky.
America. Yeah, we're very lucky when it comes to that. So I mean, yes, of course, there's a comfort aspect to it, but it running longer and being able to just kind of maintain your comfortable temp is far more efficient than it is to turn it on, turn it off, turn it on, turn it off. I mean, it's like the difference between drag racing and then just setting cruise control.
Mm-hmm. Yep.
I mean, it really is.
I was reading a interesting couple of articles the other day. It was actually from the UK. It was talking about the new inverter heat pumps and how they're actually helping the power grid issues. Generally speaking, we have really outdated power grids. I was like, well, that's interesting. There's two ways you can talk about it. Like, oh, we're electrifying, so we're taxing the power grid. But they did a study that was saying that it's actually, with high efficiency heat pumps and technology that we have now, it's actually reducing, the draw as those old units that like the one that's installed on my house right now, as soon as it comes on in AC, it's pulling 48 amps. It's either 48 or 0. There's no in between.
Right.
I'm sure you don't want to get that thing taken out. Like,
Hey, I'm just going to take some vacation days and probably, I don't know when.
I mean, I don't think that we actually need you to pay for an energy comparison when you said 48 amps. I mean, like,
Yeah.
I mean, you figure the kilowatts for that and look at what like a MultiPRO would be over the same amount of time. Like how much 48 watts or 48 amps times the voltage, how many kilowatts are we talking about there? Unless you can build a company or something, I wouldn't do it.
Right.
But
The lights in your house dim when it comes on.
Yeah. Oh, it does. Yeah. Well, that's interesting too, because I know that we talk about like, oh, well, the energy grids aren't ready for it, that kind of thing, for
Yeah.
electrification, but, or they'll say it's outdated. But like in my area, the reason why it would be outdated is just the amount of growth that we've had. We keep adding more and more and more, and they're not wrong. Electrification in an area like this can definitely tax the energy grid. But what doesn't help is using your standard builder grade bang on, bang off
Hmm.
systems. And
Yep.
we all know that. We drive around and go look at giant houses or go out and service calls on giant houses and stuff, and you've got the best countertops, the best faucets, the best everything, beautiful vehicles parked out front. I mean, you name it. And then they've got the cheapest possible thing that they can install on
Hmm.
that house.
Yep.
They might have 1,000 feet of flex and then the cheapest unitary system they can buy, which is, I don't know, it's just kind of a weird thing
It
because
is weird. It makes no sense.
no, I mean, it costs you more money than most things on a house would cost, and can also be the most expensive thing that you could plan on having to work on at some point, in the first how many ever years of owning a home. So, I mean, it's a very important decision, but most people just don't really think too much about it.
And a huge chunk of your monthly bills at the same time.
Oh yeah.
Right. Yeah, I noticed something pretty common in my area is the amount of solar panels that you see. And they're not off-grid capable solar panels. They're not systems that they've set up, that kind of thing. They've done the financing thing that they'll do
Hmm.
with the solar
Yeah.
panels, and then I mean basically it's just to offset the power bill,
Right.
which one of the most effective ways to reduce your overall usage would be a high efficiency air conditioning, and heating system.
Right.
So like I wonder like if I wonder like payoff wise, I wonder how much solar capability you have to have, how long the return of investment would be if you had just paid the, maybe the extra amount to get a more high efficiency system. I haven't ran the numbers on that. I don't know, but I imagine I would rather have, I mean, I'm going to have an air conditioner anyway. I would rather go with something more efficient than screwing a bunch of holes into my roof. I pay good money for a roof to not leak, and then I put a bunch of holes in
To see if I can make it leak.
it. Yeah. Look, if I did it, it's going to leak.
Well, I mean,
It's
the honest truth is,
gonna
is
leak.
the cost on that, because my dad looked into it as far as getting solar panels to run the house. And, unless you're going to do it yourself, set it up yourself, install it yourself, and all that kind of stuff, which could make it reasonable. It's a good twice what you would pay for a high efficiency air conditioner.
We've talked a little bit about the like geothermal, uh,
Hmm.
and in some ways it's similar. Where if you're looking at the only way to make something cost efficient is by with rebates, I mean all that means is if the rebates go away, that it's no longer a cost effective solution.
Yeah.
And
Yep.
not really getting into it too much, but if everybody's paying for your rebate, have we saved any money really? I mean, maybe you did, but maybe all of us didn't, So, um, but
But
that's
even
what I
that,
was that.
even that, it takes like 10, 20 years to even get your money back that you did pay for even after your rebates, because a lot of those geothermals, cost so much to even put in after the rebate.
Yeah, I actually just recently had a conversation about how that was the future, and I'm like, man, they've been saying that since I started doing this.
Oh, I remember when I was probably around 15, 16, and we did our first geothermal, and really awesome. Like I loved it. It's
Yeah,
a great
it's
design.
incredible.
I mean, absolutely phenomenal. Um, but at that point in time, it was the way of the future.
Right.
I don't know what happened. I
Well, I
guess.
mean, one of the things that happened, I would say, is probably just like inverter-driven technology kind of, working its way into the HVAC industry, and now your cost comparisons, you know, it's getting less and less and less, cost effective. I mean, your ROI is getting longer and longer. If you were talking about just a relatively inexpensive upgrade, you know, to go from unitary to, you know, energy efficient inverter driven systems to
Right.
making the big jump, going and digging up the place and all that. Like the nerd side of me, you know, the amount of free energy that you get out of it. Like if I bought a
Yeah.
house and it already had geothermal, obviously I'm going to be
Oh
using
yeah, I'd be all
it.
about it.
Yeah, yeah. Just like if I bought a house and it had all the solar stuff and all that, I mean, absolutely. I'm probably not going to be doing that anytime soon. I mean, I've had 3 solar panels sitting behind my shed for I don't know how long now. I still haven't hooked them up. I ran the numbers on it, and it would be like $12 a month.
Oh,
And I don't know. It just doesn't really seem like it would be that cost effective for me.
just
It's
buy
a lot of
one
work.
less Starbucks coffee.
I guess it is probably about 12. Right? Well, I don't have a choice on Starbucks, Daniel.
Oh, okay. Yeah.
It's not I who drinks it.
Oh, oh, okay.
Um, man, I'm glad she doesn't watch this. So let's see here. Well, there's also dual fuel, you know, and with Flex, we're capable of doing dual fuel systems so that you get that choice between, you know, high efficiency heat pump or whatever kind of gas furnace you want to use. I know that if I were choosing dual fuel, I'd go with the cheapest gas furnace I could use.
Yeah, same.
You know, if I could get 80% efficient, that's what I would use,
Hmm.
and call it a day. I mean, if somebody wants to go get inverter driven and then also modulating gas furnace, I guess they could do that. But
But you're not going to be using
I
that
was
furnace
digging
anyway,
around a
so
little bit, and I'm not gonna. I'll just throw this out there. I just saw a price for like $3,000 for a furnace. Um, Checking out the modulating furnaces, and I was like, whoa. Um, that's a little crazy for just a furnace. Like, didn't I'm back in the day they were like the furnace was the least expensive thing on your ticket, you know?
yeah,
right.
yeah. So that's I mean, I take it they can be very expensive. I haven't been in the market for a modulating gas furnace in a long time, but I mean, it's the best of the best, right?
Yeah, for what it is.
Yeah, pretty nice. Um, let's see. But I guess that cost difference is maybe one of the reasons why they're still not as common, right? I mean, I don't know if it's like 80/20 or 90/10 or what.
Hmm.
I've been in the heat pump business too long for me to tell you. But I just I don't see the point of getting a modulating furnace like in Texas, for example. But I'll probably, you know, 2 weeks from now I'll change my mind. Like, you know what? Maybe everybody needs gas heat here in Texas. It'll be freezing, it'll be 30. Um, I'm just joking.
I wish I had a gas furnace.
Yeah, you're not gonna hear me say that. Uh, like I said, I've done this too long.
uh,
Well, you got some experience with modulating gas furnaces, don't you, JD?
Oh yeah.
Man, are they
Yeah.
hard to troubleshoot and stuff, or
I mean, there's just more components to it. Multi-stage gas valve and those things act up, and you have issues with those, or so there's just more stuff to go wrong with them too.
I got you.
Because your inducer motors multi-stage, just like your gas valve, and those things mess up. Then you have, you know, uh, your pressure switches. You have like way more of those. Of course, those always get plugged up. So there's just it's just more issues really.
So when we're talking about like a modulating gas valve, we're talking about like multiple speeds or like variable.
I
You
mean,
know,
there's like
like
there's
this, or
different.
is it like 20, 30, 40, 50, or I mean, how does that
It
work?
it's like normally starts out at 50, set like 70, and then 100, or and then they have same thing with your gas valve, same thing your blower stages, along with your gas valve, along with your inducer motor as well.
Mm.
So it's like I say, it's just there's more safeties, there's more pressure switches. To
I
me,
got you. So
you just have more issues with them.
so you have a modulating blower, a modulating gas valve, a modulator
Yes.
inducer,
Yes.
a modulating inducer fan motor.
Yep.
Okay.
hmm.
Well, I mean, I'm glad somebody figured out how all of it should work together.
Oh yeah.
Hey,
And
we had
then a lot. then a lot of times the installers don't set it up right either, because you got to set up all the different stages properly too, And if you're switching to LP, which a lot of it was LP where I'm at, so then you have to set the different stages properly, and they just installed it, changed the spring and leave, and then of course then it would be all set it up and may cause even more issues.
Yeah, I definitely could see that.
Hmm.
I've always wondered about the condensation, like trying to get that out of the. I mean, do you see like premature failures in their combustion chambers in modulating gas furnaces, or no?
I mean, yeah, you get that too. I mean, like again, because a lot of it's just based on them not having it serviced too. If you have it serviced, then yeah, they're cleaning the pressure switches, cleaning the drain traps, and you have more drains and all that too. So
I can't believe it. So you're saying if it's installed properly and it's properly serviced, it'll work just fine?
yes, you'll have less issues with it. Imagine that.
Sell those maintenance plans. Come on.
Yes.
It's not a maintenance plan is not just something to keep the guys busy when, in the shoulder season, right?
Exactly.
There's a purpose for it.
I've been on a
Absolutely.
10-man crew changing filters out of 5 rooftop units. I've done that before.
How many times you changed those filters this month, James?
Well,
It needs to be done again.
It's up to you to put the date on them. So if you forget, then you're not lying, right?
So we had a question come in.
Oh, okay.
From Todd. Thanks for watching, Todd. Why does the 5-ton Flex Ultra lose so many BTUs at 5 degrees versus the other sizes?
I guess I hadn't really looked into that.
Well, I'm going to do it right now. I'm going to greedcomfort.com.
That's what I was getting ready to do.
All right, you can go there too. Everybody can go there. And if you're at home, you can play along with us. If you go to
We go to resources, system docs.
Oh, you go to resources and then system docs.
Oh, you go the other way. You go the sales direction.
I go the sales direction. Excuse me. Documents and then system documentation / literature.
Are we talking about the 410A or the R32 one?
Probably R32.
I would assume.
I don't even remember what 410A was.
Yeah, I would assume we're talking about R32. It's 2026. Nobody even remembers 410A.
Yeah, what's your deal?
So that was last year, man.
We'll use the skip to on the left-hand side, go to central air. And then Flex Ultra R32. There's 3 different options there. We're just going to go with that top one, I suppose. And then we should have
extended ratings right there.
Did I? Oh, I skipped them.
Yep.
Did. And then, yeah, extended rating. We'll go ahead and open that. And then we're going to go ahead. I'm just going to guess and say it's probably the last page.
Probably at the very bottom.
Yep, very last page. And while I'm doing this, I'm going to go ahead and check out AHRI too, because we may be using the AHRI 5-degree value rather than the 5-degree value that's here. I don't know. But if we look at 5 degrees at 70, you're saying, let's see, 45,000 BTUs. So we're going from a rated, I believe the system is rated at 54. I can check back real quick off camera and look at the submittal. Okay. Yeah, so we're rated at 54,000 BTUs at 47 degrees. And yeah, you can see that 54,000 at 70, at 47 degrees, excuse me. And I believe it's, I can't remember what it is, like 68, I believe, internal temperature, but we've only got 70 written there. So we're going from 54,000 to 45,000 BTUs. And I'm going to go and look at what we have in AHRI for the FXU 60. Oh, okay. Well, AHRI shows 54,000 BTUs at 5 degrees.
We might actually have a typo there.
Yeah, well, like I say, the AHRI data shows 54,000 at 5 degrees. So this, and it's rated at 54. So technically it's 100% heating capacity at 5 degrees. Whether that's with the FXE or FXU indoor unit.
Interesting. So great question. We'll take a look at
Yeah.
that, make sure it's
Yeah,
correct.
right.
Joe's asking, thanks for joining us, Joe. Will you be introducing anything new at ASHRAE? We'll talk about that a little bit more later, but I think we don't have, as of yesterday, we talked with Justin and he said he doesn't have an update at the moment, but there will be some introductions of some new technology. So
I'm gonna grab that, let's say the 48 and see what we got at 5 degrees. 48. So I'm not really sure where we're, maybe if we're using this capacity chart, maybe that's where we're seeing the drop at 5 degrees, but I'm not sure. Or we're talking about from maybe we thought that the nominal rating would be 60 because it's an FXU 60. Totally understand that.
yeah,
But there is some variance that manufacturers are allowed to have in the capacity versus the nominal capacity rating. Most 5-ton units that you'll see are rated at a little bit less than the 60,000 BTU nominal rating. Particularly after the M1 blower testing change, there was a lot of manufacturers did not a significant derate, but some derate in order to still hit the efficiency ratings that they needed to hit.
it makes sense. Yeah, Todd put another entry in there in the question. It's the exact same at 5 degrees as a 4-ton. He says, yes, I use this site all the time. We're glad you're on there.
You know what? You said it's the exact same as the 4-ton. If you wouldn't mind, let's see if we can scroll up a little bit and see if there's any difference between the 48 and 60 heating capacity chart.
It may have been copied pasted.
Let's just go with that first one there, 26,200. And then, no, that's not copied and pasted, is it?
No, it's not.
45. Okay, yeah. Well, no, it showed 45 on the last one, didn't it?
Did it? Yeah,
Not copied
yeah.
and pasted.
There's a little bit different numbers. There's a 20.
Yeah,
Yeah, the numbers are a little different between the two.
a little different, but yeah, now I'm kind of.
Yeah.
I'll go ahead and send the note over to our product management team and see if we can't get them to verify that.
Excellent.
I'm gonna do that right now. How about that? How about that level of service, ladies and gentlemen?
So, while James is typing an email over to product management, we'll move along to our next segment talking about there's no one size fits all answer. Let's see. We were talking about this yesterday, retrofit with existing gas furnace, choosing what you should use. Like, do you put in a dual fuel? Do you not put in a dual fuel? The dual fuel often makes sense if you're doing like a change out. So retrofit and you've already got a furnace there. Flex is a good option. You can use the case coil and replace it with a heat pump and then, move along. But you get to new construction and you pretty much got a clean slate. But then the issue there is, of course, we're trying to win the bid, right? So high efficiency kind of becomes a roadblocks. But if it is new construction, you've got design for full electric. If you want it, then the flex heat pump's a great option. The MultiPRO, used in the same direction or the same way as the flex is used as a 1-to-1 with an air handler is a great option. And then importantly, and I know JD was kind of talking about this as far as install goes, propane versus natural gas cost differences. Do you have propane or do you have natural gas access? A lot of places in South Carolina, they're full electric. So the only option you would have to have a dual fuel would be, bringing bringing the big tank in, and getting it put in the backyard. That was always a lot of fun to to play on as a kid.
Oh yeah,
At grandma's house.
that's right.
uh,
Or
um,
open it up and get chased by all the mud daubers that are in there.
yeah,
Yeah,
exactly.
wasps, bees. Yeah.
Or wasps.
You can also paint them, make them look like a pig or a cow,
Yeah.
something like that. The next segment is stay heated or chill out. And it looks like Daniel's heated. What's Daniel heated about?
So you want to hear what I'm heated about, James?
Yeah.
Yeah.
All right. So here's my just my really gets me, like
Yeah.
blaming temperature fluctuations on the controllers, like just the dead band alone. Like um I, it just makes absolutely no sense.
My unit's overshooting temperature. Maybe it's oversized or
Yeah. Yeah,
maybe.
that.
Yeah. I
I
put a
get you.
1 ton unit in my bedroom. Why is it overshooting?
Because you got a small bedroom. It's not because the air conditioner's too big.
Right.
Take out one of those walls, and you won't have that problem anymore.
That's right.
Open a
Okay, yeah, I see
window.
what you're saying. Or like you get a call in the tech support, and they're like, "Hey, I got this unit that's installed. I'm looking to try to get a wired controller for it."
Right. And you go,
Why?
why?
Why are you trying to get a wired controller for it? And it's always, well, unless it's installed like 6 inches from the floor, which has happened a number of times,
Yes.
or it's behind
With a
like,
high wall, right?
yeah, it's behind the Hummel figurines and TV, console and the Elvis collector's plates and all that, and it's just not quite maintained temp, that kind of thing. But yeah, another one is why, you're wanting that wired controller. So yeah, I can definitely see your point there. So they're always wanting to make adjustments to it and stuff like that, right? Which many of our controllers offer that opportunity, do they not?
Yes, they do.
They definitely do. However, from our experience, I can honestly say that if you have a temperature swing like you do, like it overcooling by 4 or 5 degrees, and then you drop you would correct the temperature by 4 or 5 degrees, then you're going to have 4 or 5 degrees temperature difference from the corrected temperature, which is normally a clear indication that it's oversized.
Mm-hmm.
Yeah.
So we talk a lot about the units doing a really great job of protecting themselves. And one of the things it's not going to allow you to do is have it come on for 20 or 30 seconds and then cut back off. And then come on for 30 seconds and cut back off. Most of our equipment, and you can correct me if I'm wrong, but it has a 6-minute minimum runtime.
Mm-hmm.
Right?
Yeah.
Okay. Does anybody know what capacity we're providing during that 6-minute runtime?
100%.
Maybe.
It depends on set point.
Well, if I've got a
Right.
temperature swing like that, then I'm probably going to have a pretty substantial delta.
Right. Good point. Good point. Yeah.
But by the time it's able to come on again and run, I know I'm not sure exactly what it provides right out of the gate, but we also have an oil return function that runs, and like I know in cooling, it'll run a little bit faster than it normally would have to in order to ensure that it got oil back to the compressor, right? And if you're running in minimums a lot, you're going to be running oil return a lot. And so that's going to be even more capacity that you're providing to the space or taken from the space than you need, right? So you can see a pretty substantial temperature swing there. And then, like I say, I mean, doing the temperature correction just moves that set point that further down or up, and you'll still see that swing. There are a handful of different things depending on the system that we're talking about. That we can do, like if it's something that's already installed, we will absolutely jump through a bunch of hoops and try to help the system, help the homeowner,
100%.
building owner, to try to get it to work in a way that they would like it to work. We definitely don't go, hey, you oversized it and then hang up. I can tell you that. But we do have to kind of talk about that at the beginning and then talk about things that we can do to try to help mitigate that. And if that doesn't work, then we have to return back to what we were talking about at the beginning. You know what I mean? And
Yeah.
so, I mean, we've had applications where, I mean, I can give you one really great example. It were 1-ton units. They sent pictures of the rooms, and it occupied enough space on the ceiling that you could tell it was too big, for the room it was in.
Yeah.
But it was a 1-ton unit in 110 square feet.
Hmm. Had to do it.
Yeah, I'm not a scientist. I don't know what kind of insulation they had in the walls, but I know it wasn't not insulated. I mean, there was a wall there, so I mean, there's that. There was at least that R value.
There wasn't just slats.
Yeah, I couldn't see the sky, looking through the ceiling, but
Well, it's I think it kind of goes back to what we were talking about in the beginning of, that misinformation about heat pumps not being able to heat in cool weather,
yeah,
or cold weather, not just cool weather, but cold weather, below zero. It goes back to that same thing where whoever started the rumor that you couldn't oversize an inverter heat pump, um, did us a huge disfavor, because everybody's heard it before. Like, it's going to
Oh
ramp
yeah,
down. You can't oversize it. And so we get things like that, those rules of thumbs that we just kind of run with because it's what we're told. It's what my mentor told me. It's what my boss told me. It's what I heard in a training class, or whoever it was that you might think a lot of, and they just said it, and then you run with it. And then you've got
right.
this idea out there, you can't oversize them, and that's just not true. Um, you can oversize them and undersize them.
Yeah, or even the people that turn it down at night and turn it up in the morning, or that's going to cause them to overshoot, because every morning and every time you do that, it's going to have to relearn. So that's going to overshoot and eventually, um, you
Bring
know,
itself back down, ramp down a little.
bring itself back
Yeah,
down. But
yeah.
these units are designed to be set at a certain temperature, and that's for optimum comfort, and then they're going to keep it that temperature.
yeah,
Yeah, and that,
set it and forget it and all that.
yeah,
Yeah,
that goes back to, I need to shut it off to save energy, right?
exactly. Yeah,
When in reality, maybe I just need to leave the temperature alone and
yep,
let it save its energy on its own.
yep. Let it
Yeah,
do what it's designed to do.
the only time like a office in my backyard, honestly, and just got a mini split here. The only time I turn it off is like a long weekend
Hmm.
through the holidays or something like that. Or if I just think ahead, I'm like, I don't want to walk in here and it be 45 degrees, or 90, so I'll just go ahead and maybe set it back a little bit, but not a lot, and I think that's what people found too with the smart thermostats and the scheduling, and they're using their phone and the geolocation thing that they do, the
Hmm.
geofencing.
Yeah,
The first time someone forgets to turn it on 2 hours or whatever before they get home, they're like, I'm never using this again.
right.
I got usage data from when I was working at another manufacturer from a thermostat manufacturer, and it was on average about 2 months that people would use their smartphone and all that and their settings and all that kind of stuff. It was about 2 months until people just kind of went back to using thermostats the way they normally would use them.
That's funny.
Yeah. I think everybody, I mean, I think a lot of people do like to have some active, like act doing something to save energy.
Hmm.
Like they put effort into it in order to save energy. Like I can get that. So yeah, instead of 70, go 68 in the winter, and
Well, I
save
mean, it's kind of
save all
like
the money you need to save.
turning the lights off when you leave the room. Like, some people care, some people don't, but some people want to be able to kind of control that little bit of, hey, I'm saving a little bit because I'm turning this off.
Yeah, and some people have their outdoor lights on right now, probably.
All night
Um,
long.
I'm looking at it right now, seeing that they're on.
They've been on all day long.
Yeah, well, I save a lot of money with my MultiPRO, so just leave my lights on. But yeah, on the hysteresis conversation, that temperature swing and all that. Yes, almost all the time it's because it's oversized equipment. Um, you know, but so we need to vote though. Let's vote on the panel. Should we stay heated or chill out about this?
I want to stay heated.
Okay, and Daniel was already heated. I guess I'll stay heated too. Jesus isn't here to be a contrarian, so. Uh, but we would like the audience to vote too. So, should Daniel stay heated about people blaming like controllers or the way it's controlled on temperature swings, or should he chill out? And you vote by saying stay heated or chill out using the question mark icon to the right of your screen. Okay. Speaking of which, question mark icon. We will come back to that and tab. We will count. We'll count the votes after this.
We'll tally them
We
up.
will tabulate the votes.
Tabulate? Is that? I don't know, man.
I don't know.
I don't know either.
I'm not an English professor.
Yeah, I know. I do heating.
We did have a question came in. We'll from Todd. If you use a case coil on the Flex R32, how are you going to shut the furnace down in case of a leak? Which is a great question. You know, if you're not familiar with or haven't seen the Flex case coil and how they built it, they have a control on the front of it that's movable. You can move it to the side or whatnot. But your controls run through that coil, through the case coil, so that if it goes into alarm, it's going to shut the system down.
Yep. It'll open Y or open, there's even temperature sensors on there that if it gets too hot, it'll open W or Y, whatever it needs to do. And again, next or couple weeks, and on 29th, we're doing Tech 90 on the dual fuel. So.
Oh yeah, you asked for me to be on that one, so
Yes, sir.
I'm gonna
Yes,
join
sir.
you on it.
Yes, sir. Thank you.
I thought you were gonna say you're gonna skip it.
No.
So I'm gonna skip it.
So we'll dive deep into that one on the Tech 90 as well. So
Great, that's awesome.
Oh yeah, you got a W1 in, a W1 out, a W2 in, a W2 out.
Y in, Y out, Y2 in, Y2 out.
Oh wow, yeah, you do.
Yeah, so there's freeze protection and overheat protection on there.
Freeze protection? Who needs that?
Yeah.
You're supposed to just let it swim until it quits.
Right.
Who needs an accumulator, a low pressure switch, right, JD?
That's it.
Yeah, so yeah, W1's in and out, W2's in and out. You got a G in and out and a Y2 in and out. Wow, there you go. You got everything you need. How about that? I also found that on GreeComfort.com under the Flex Ultra with a coil matchup. I was able to find it there. See, we don't know everything off the top of our head.
It's a lot to keep up with,
I don't think anybody thought we did, but still. Even being able to focus on one brand.
We all thought you did.
Oh well.
Yeah, James probably knows.
You're the inverter genius.
There are things that you ask me, and then there are things that I know. Sometimes they match, sometimes they don't. All right, it's just the way it is.
I missed my opportunity. I should have just got you a lab coat and sent it to you for Christmas.
A lab coat? Oh, okay.
Mad scientist down in the out in the shed in the backyard.
Do mad scientists sell a lot of air conditioners?
Well, this particular one does.
Okay, all right. So let's take a look at some of YouTube comments that came in. Let's see. Our YouTube channel is at GreeComfort. Second.
Oh yeah. So we got a little segment here for you. This first one, we were discussing it during our pre-production call yesterday, and unfortunately Jesus is on a plane, so he couldn't be with us. But we wanted him to have an appearance since he couldn't be on the program, so we decided we'd run a clip from that. So go ahead and roll it.
Hey man, we're here prepping for Talking Comfort Live. Jesus had a really good point. He apparently absolutely loves dealing with defrost. He had some things to say about the Gree defrost.
Yeah, so when we think about defrost, we think about traditional systems where they're usually off of a time defrost. But GREE inverter-driven systems actually go off of an intelligent defrost, which pretty much combines, workload rate, system temperatures and pressures, and variable period and variable defrosting capacity to be able to initiate that defrost cycle. So we've kind of gotten away from just the time defrost, as we all know, it doesn't really fully de-ice the coil, and it really just doesn't help out the system or even your indoor space, to reach the appropriate temperatures inside. So that's kind of what GREE does on the inverter-driven equipment. It's a little bit different than just the regular unitary single speed heat pumps. I don't know if anybody else wants to add on to that.
Well, I would add that your time and temp defrost was the standard for heat pumps years ago. Most manufacturers are going into more of a temperature differential across the coil to detect when there's frost in it, and GREE is using that and more to determine exactly when that machine needs to go into defrost. And then the other thing that GREE does and does very well with defrost is, because you have an inverter-driven compressor, they can ramp that compressor speed way up and get that defrost cycle done in a very short period of time. A lot of our defrost cycles on GREE equipment is less than 2 minutes, and it's right back into heating.
Right. And I mean, during the defrost and everything, pretty much on the inside, it'll shut off. So that way you don't, you're not getting those cold drafts throughout the house. So.
And the other thing you got to think about too, and I see this missed a lot when it comes to defrost, not realizing the machines have to defrost and stuff, especially in your colder climates. It's highly important that these systems be elevated off the ground. They'd be on a stand, they'd be on a wall mount or wall bracket, something like that, because when that thing goes into defrost, that heat pump's got to be able to shed that water away from that machine. You don't want it to be able to defrost and then the water get on outside the unit and then start building what we call an ice dam, because then you'll actually build ice all the way back up to that condenser coil, which is a bad idea. So we absolutely need to make sure that heat pumps are installed elevated off the ground.
Another thing about the base fan heaters, like all of the products come with base fan heaters. Well, that's a large part of it, to make sure that watershed's getting away from that unit.
Right.
And also not putting the plugs that come with in the packaging in the bottom.
Yeah.
I'm glad you brought that up, Daniel, because they do still ship them with it, and
Yes.
but in the U.S. market, it doesn't work for us. The plugs do not get put in there. All that's going to do is help hold water in the base pan that could potentially freeze, not where the heater is at, because the heater's not going to let that happen, but it could freeze under the condenser coil, and we don't want that to happen. So we absolutely, that's why I was talking about elevating the unit, because when you elevate the unit, you give the thing the ability to shed that water away from that outdoor unit, so that we don't get ice damming and freezing and actual potential damage to the condenser coil.
So I would say, I mean, it's safe to say that, GREEs came a long way from traditional just defrost cycles, and where they're incorporating intelligent defrost cycles to be able to fully de-ice that outdoor coil and get you the temperature that you need inside, even in the cold climates. So we just want to thank you all, and especially Ramsey Mike for the question, and we hope to hear more from you.
Really makes me miss Jesus. I thought one of the funny things about that clip is that he was talking about old school, defrost timers, and Greg was the one who came with the new school stuff.
That was good. That was good.
Kind of backwards from the way those conversations normally go. But,
All right.
I know I mentioned it earlier, but hey, check out our YouTube channel at GREE Comfort. That's where a lot of this, that's where all of this stuff is at. But also on other social media platforms like Instagram and Facebook and TikTok and Red Note, if you're still using that, there's a lot of places to check it out. And X, can't forget that, formerly known as Twitter. It's also on X.
So we have any
let's
more?
take a.
Yeah, we have any more of these questions that we can do live now, or?
We've got some more YouTube comments to respond to, but we may have some
All right.
questions. Daniel, you can check it out for us if you don't mind.
Let's see. No more. Let's see. We got a bunch of stay heated entries.
Oh,
So it looks like I can stay heated
All right.
about
We're
that.
gonna write down those chill out ones if there's any chill out one.
No, there was no chill outs.
I'm gonna go find their Grease Select dealer login. Just joking.
We're watching you. No. So the next YouTube comment, you want to go to that one, James?
Yeah, do that. Yeah, it's under the video selecting the master zone when installing a Gree multi-zone system. We've got River Place Tree Houses says, I have Gree dual zones in 5 places, and this doesn't seem to work for mine. I bought and installed them in 2023 and 2024. Is this a newer feature? Anything I can do to sync the 2 zones so they're in the same mode or create a master zone like this?
Well, unfortunately, we apologize for the confusion there. That was actually for a MultiPRO. The video was about MultiPRO, not multi-zone. So you cannot do that with the multi-zone.
Gotcha. Okay, so the title, I guess we need to update that to MultiPRO. Okay. But yeah, I thought the yeah, we can't set a master zone on the multi-zones, can we?
nope.
No.
A priority zone or anything like that?
No,
No.
Okay.
there was only one model that ever had that ability, and it was the Multi-24. I believe it was the AO, BO, and CO.
The
For
dip
whatever
switch?
reason, they had the dip switches. Yeah.
Gotcha.
So
Interesting. Okay. Well, I'm sure there was an application somewhere globally that was 2 tons and was like probably multifamily or something like that. Yeah. Okay. Let's go to another one. For the video, very popular video, how inverter-driven compressors work, and it has Greg talking in it. So if you miss Greg this week or this month or whatever, you go look at that video. He's in it. From Mark.R8900. Thank you for a great explanation. I guess we'll tell Greg thank you. When I checked U to V, he got 7 ohms. When I checked U to W, he got 7 ohms, but V to W, 0.9 ohms. Does this mean the compressor is bad?
Yeah, as long as his meter's good.
He's got some strange error codes. And oh, this is on a. Oh, okay. It's actually a pretty good thing. He's getting error code 83-16, 83-56 on a carrier heat pump. So he's using our inverter video to troubleshoot a carrier heat pump.
yep, that's pretty cool.
So I think you should probably just replace that carrier heat pump with a Gree. However, if you don't want to do that, yes, yeah, you've got a bad inverter compressor, right? Everybody agree with that?
Yep,
Completely.
I agree.
But if you think they've got a bad inverter compressor, you can vote using the question mark icon. But yeah, definitely. So V, let's see, U to V, U to W, and V to W should all be equal. I mean, give or take, we're talking like 0.1 ohms, right?
Right.
So he should have 7 ohms on all 3 of them, but instead he's got 0.9 on one of those, which means that your windings are melted together, reducing the overall resistance on that coil, on the coil for the compressor itself. So it's not going to be able to generate that signal. It's not going to be able to turn that compressor. Okay. So if you have any of that on any inverter-driven compressor, even if you open up your washing machine and you had that, you have a bad motor. This is just us trying to help you guys just troubleshoot anything inverter-driven. Another comment under how inverter-driven compressors work. Oh, okay. This one's a good one. Yes, they are energy efficient, running the compressor as needed at varying frequencies. This is son of knock 2153. But what is all that when they fail so What is all that when they fail so frequently and abysmally? Either the inverter board fails, the compressor fails, or both. So JD, since you work in tech support, and me and Daniel don't work in tech support, we don't know anything from a technical standpoint. What is your opinion on boards and compressors failing often? Do you see that? Do you see those often?
I mean, I would say I don't get very many calls on that. I mean, I get a lot of calls when they think it's that, but it's a lot of times something else like a sensor or, refrigerant, or, they didn't pull a good vacuum, they didn't charge it properly. Line set's too short, wrong size line set.
I got
There's
you. Okay.
a lot of other things that it generally is, rather than, a bad board or compressor. But that's even, I worked for a guy who that's the first thing that he wanted to do at every unit. Let's throw a board at it and see if that fixes it. And if that doesn't fix it, then we'll spend some time on it. I'm like, how about first time there, let's try to fix it.
Well, look, I mean, we all know that the money you made installing it is already gone.
Right.
So no, but I mean, one thing, I think a concept that I like to try to get across is if I take a capacitor and a contactor and a relay and a defrost board and let's see, a defrost sensor, basically I take all of those things, right, and then put them on a board, right? If any of those components were to fail, that I would be replacing those components, but I put all of these things on the board. So therefore I'm replacing the board. So it's not the same thing as like I've always got defrost boards going out. This would be like on any call where you have a capacitor, a contactor, a relay, a sequencer, an unloader, a blah 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 blah, just anything that you can think of. This is all on this one board. And I think one of the reasons, I think one of the pain points is the amount that's charged for these boards by most manufacturers is incredibly expensive. And I think that's one of the big pain points. And another pain point is how other manufacturers handle their warranty process. So if you have to pay $2,000, which you shouldn't be paying $2,000 for a board, but if you're having to pay $2,000 for a board, then go change it out and then bring it back and hope that you get credit on it like it's under warranty. And of course, you're going to have a very, very strong opinion about inverters. But if you have a hassle-free warranty, where like we do, where you get the board, and even if you were paying for it, we do not charge an astronomical amount for stuff like that. I mean, we're not in the business of trying to make money off of boards. Another benefit, right, which has its own challenges for other things like user interface, stuff like that. But one of the benefits of dealing with a global manufacturer like GREE is that much of this is manufactured for the global market, right? These aren't custom boards. So if I, as let's say McIntyre Components or something, I decided I want to make an inverter-driven heat pump, I go and buy a custom board, go get it manufactured, made, and all that. I go buy this custom board for my custom unit and my custom market. Expensive, expensive, expensive. Now, if everybody trusts the name brand McIntyre, then maybe there's something, maybe there's a reason that you buy it. However, that's the reason why it costs so much. But since our inverters aren't as custom, they're used in many other different products like that, and GREE also manufactures the inverters themselves. They're not nearly as expensive as something like that, And like I say, so even if it were to be more of a common thing, I mean, I would argue that thermistors are more common than anything else we got.
Yep.
But I mean, this is my 10th year dealing with. It is officially my 10th year dealing with GREE manufactured products. It's got the lowest warranty rate that I have seen out of any of the other manufacturers I've worked for. So as far as compressors going out, really, really rare. Boards going out, well, like I say, if you've got one board that does everything, then yeah, if something goes out, it might be the board. Right? Do you guys agree with that?
100%. I really like the way you put that. It makes a lot of sense, and it is ridiculous how much they charge for boards on other things, even stuff that's not heating and air. Because when you see the cost on this side of things, and you're sitting here going, wait a minute, does that board for my washing machine really cost that much? It's kind of crazy.
Of course
But
it
how,
does.
but how about, being that board does so much, let's put a surge protector on there.
There you go.
You
Yeah.
know?
Good point. And
Yeah.
if you're constantly replacing boards and compressors on the same system, maybe you need to dig a little deeper and find out what's causing the issue.
Yeah. And an adjustable surge protector, might I say.
Yeah, adjustable something a line monitor that's
Yeah.
going to actually protect the system.
And they're offered by a lot of companies,
Yeah.
companies that you know and trust that you buy all kinds of things from. So go check those out. The big names. There's also a bunch of custom ones out there, and there's probably some you can buy 500 of them direct from China if you want. It's up to you. If you're in Florida, get one.
Yeah, just go ahead.
I mean, lightning's like there's lightning every day. There's surge like every day. It seems like so. I mean, not everything's
yeah.
protect from lightning, but I mean, anything is better than nothing. And I mean, the fact is, I've got a like a $200 TV that's on a surge protector right now. I mean, I would contend that the equipment's worth more than that. Um, you know, the cable modem for my internet that I don't even own is on a surge protector. Um,
Right.
but yeah. Anyway, well, I appreciate that, JD, giving us a clue into the life of tech support. Since Daniel and I have never done it.
Yeah. Both very well how important those are.
All right. So next, let's talk about HR. You got any special things coming up in HR?
Well, for one, we have a cocktail party Monday night that you
Okay.
won't want to miss.
So if you're in,
to all of our customers, please make sure you sign up.
if you're coming to Vegas and you can get out of the casino for long enough to join us for a cocktail party.
Yep.
Cocktail party coming up.
There's going to be a product update. We have a special room dedicated to us. I'm not sure the exact time on that, but did we have a video to run on that? Okay, well, never mind then.
There are many exciting products that are going to be coming.
Yeah.
And as always, with every HR Expo, there are also products that we just don't carry. So if you see refrigerators and stuff like that, that's just something that we don't carry those. But I mean, you never know what the future holds, though. We'll see if I can steal this one this year. Take it with me. But
I don't know how I would get it home, but I think you can drive it to your house, James.
That's a long way, man. That's a long way.
It's only a few hours. Come on.
It's got to be stored up right and all that too. I can't be doing that. Can't shift it sideways like you can a mini split, right?
It
No,
drives me crazy seeing all of the products because it's like I want one of those. I want one of those. I want to take the washer dryer home and plug it in and play around with it.
Yeah. Now I can speak to some of the updates for GMV for our commercial equipment. We're moving to GMV 9, currently GMV 6. So it's 50% better in numbers. But I did get to see some hint of that and what we'll be offering in the A2L products very soon. So it's already as good as any of the commercial stuff that we carry, but there's also brand new features and benefits on that system.
Awesome.
Yep. And it gives you an opportunity to see all the other products that we carry as well. Okay. So, do we have any more questions that have come in? Would you mind refreshing?
Yeah, let me take a look. One, Jeff, thank you for the comment. Love your warranty. Parts prices are very fair. And then another comment from Jeff. He says, modulating furnace. Sure, you've seen the Navian hydro furnace. Like 15% low input, no pressure switches, 90% modulation, set discharge temp, cool machine. Heat pumps ain't so good. Question mark, question mark, question mark. Yeah, that's pretty interesting. That'd be a good pair with the flex dual fuel, right?
Oh yeah. Yeah, I mean, I think given that, given all the options, if somebody's wanting, the best possible thing they can come up with, I think that would be it.
Yeah, I always keep going back to, like, I love redundancy. I love a backup. If anything were to happen, per se, to the outdoor unit, then I'd have my furnace running, or that way. I just like the idea behind dual fuel, even though I just live in the South, and it
Yeah,
doesn't really matter.
I think it's hard to turn redundancy off if you're attacked.
It's true.
I mean, if you work on stuff that's broken all the time, then you expect things to break.
Right.
I mean, it's an inevitable thing, right?
Craig put a comment in here. Thanks for watching, Craig. I will send you an email. He was asking about the cocktail party, so I'll send you the invite.
Okay. Any other question?
That's it.
I can't believe it. Must be a perfect episode. Everybody knows everything.
Hey guys, so just don't forget about the Tech 90 coming up January 29th. Again, we're going to be going over the dual fuel coil that we have, and how to set it up and properly install it, and all the cool features of that.
That's awesome.
Looking forward to it.
Yeah, I've got a lot of questions.
Yeah, I
Cool.
do too, actually.
We'll answer them. We'll answer them live.
Yeah, no, that's good. That's good.
Yeah, I haven't had a chance to get one and wire it up myself, so I'm interested to see it, done.
Oh
It's
yeah.
just,
Yep.
I don't know. I still have to put my hands on things. Like, manuals are great to read. It's always good to not use it as a knee pad. But I don't know. Maybe it's just a me thing, but I like to put my hands on things and see how it works.
Well, the size of
Absolutely.
these manuals aren't good knee pads anymore. They're
True.
little bitty manuals now. Yeah.
You need two of them.
Yeah, you need two of them. Oh, inside and out, right? You got your two knee pads now. Let's see. All right. So, if you could do us all a favor and go to Greek Comfort on YouTube and subscribe, that would be great. And if you're watching this video after the fact, if you go ahead and like it, that would be great too, because then we could just do YouTube. Right? Do YouTube for a living. But and don't forget about our Contractor Pro service app, available for you from your smartphone at grepros.com, so that you can get the answers and information that you need in the field when you need it. We are not open 24 hours, but you are.
That's it.
Okay. What else I got? I guess that'll close it out for the first episode of the year. I thought it was a really great episode.
Oh yeah, I enjoyed this, and I look forward to seeing everybody at AHR.
Yep.
Yeah. Don't forget, GreekComfort.com is open 24 hours.
Yep.
Yeah, good point.
That's right.
We got our tech tool there, so at your fingertips. So it's like we're there, but not.
Yep, that's right. All right. Well, that's it for today. Remember, at Gree,
We're by your
We're
side.
by your side.
Please like or subscribe to our channel at Gree Comfort on YouTube, and head over to greecomfort.com/training for more tips and tricks and all the information you need to help you out in the field. And that was a good show.